There's a 1995 movie, Apollo 13, that has a scene in it that I just love. So in this movie, these astronauts are up in space, and everything that can go wrong, of course, does go wrong. It's a little like chemistry in that case. But in this specific scene, the CO2 levels, the carbon dioxide levels, are getting really, really high. And so, of course, this is really dangerous for the astronauts. And so the lead on the project challenges his team on the ground that they have to fit this square peg in a round hole. So in that scene, what do you see? You see a whole bunch of what looks like just trash that's in front of the crew, and they have this immense task at hand. And so that's what my challenge is for you in this lesson. Take the recycling. Take these, cardboard tubes, styrofoam. You can use test tubes if you got them. If not, there's like shot glasses you can use. Any kind of plastic or clear container. Duct tape, masking tape, electrical tape, whatever kind you want. But my challenge for you is to use the supplies at hand and create a spectrophotometer. You have all of the skills that you now have learned from Arduino to create a working and functioning spectrophotometer. So I'm not going to give you step-by-step directions on how to do it. When I've done this with my students, I loved it. They loved it. It was a creative time. You get to have fun and experience things and design your own device. You could use your light-dependent photoresistors if you want it to be in the IR range. Use your IR light. You can use op amps to increase the gain. You can use push buttons, or you could just not go fancy at all. You could use the back of DVDs and peel off the grating there, and so now you've got both an analyzer and a source and a detector, just like you're learning an instrumental class. There's just so much to it, to Arduino, that you now know. You have the skills and the skill set to troubleshoot, to think, to work, to develop instrumentation using these Arduino devices, which has been my goal for you all along. And so I want to see your creativity. I want to see you create amazing devices. Now, my suggestion to you is to start out simple. Don't get crazy at first. Design something very simple. You've got a light and you've got a detector, and you need to put your sample somewhere between them. So use these tools, these recycling parts, in order to create that. Prove that that works first, and then start making a calibration curve and making it so that you can test, figure out what's your sensitivity, what's your selectivity, whatever you want to do, all the parameters that you've learned about in class, test them. Figure out how they work for your instrument, what those variables are, those figures of merit. But in the end, I want you to have a working spectrophotometer. I want you to have something that takes light, analyzes a sample, and you get working data at the end. You can use an RGB anode or a cathode and really control which wavelengths of light you're looking at. There's so many different ways that you can design your spectrophotometer. It's just your brain. Your brain's the limit. Nothing is holding you back. You've got pieces, you've got parts, and you'd be surprised what you can create with just these little bitty tools. And so just like in the Apollo 13 movie, you can create something awesome out of nothing, just using your troubleshooting and your experimental design skills and things that you have learned so far in all of these lessons. So go create, and I do want to know what you create out of it all.